Basically what BioDT is, for me, in a simple way, is a combination of the supercomputer power, of the super modeling advances and technologies represented by people with these skills and their experiences. And our role in GBIF is to make sure that the relevant content is available for this big game of the supercomputer and supermodeling. We bring together use cases where this modeling and this supercomputer power and this content come together, some applied real-world problems. We have 4 big streams of these use cases. So one of them is environmental change. It sounds very broad and distant, but it's actually everybody's concern, whatever you do. If you work in the industry, if you work in academia, if you work in applied sciences, if you're involved in the decision-making, policy, the world is changing very rapidly. There are natural changes that happen without human influence. There are changes caused and influenced by human involvement. We need to understand that, and that's been in focus of ecological research for many years now. But whatever big effort we put in collecting the data, and we can never cover the planet with dense enough layer of dots of observations or clusters of these evidence grains. So to compensate for our inability to cover the planet with that, we do modeling. For modeling to work, to be able to model and measure environmental change, relevant content for the well-studied areas should be available, and that's the mission of our work package in the project. If we go further down to more specific scales, there are use cases which are connected by the fact that certain species have important statuses important for human beings, and that includes species which already now suffer from the environmental change. Threatened species, red-listed species, and how they react to the changing planet. On the negative impact side of the species on the biodiversity systems, on the systems that humans modify, we have invasive and alien species, species which aggressively move to where they shouldn't be. And to understand and to model the decline and the increase of the species in relation to humans is a very important problem, both scientifically, but also in the applied context. One more line of the use case is, and maybe the most difficult one, is to bring species interactions into that research context. Lots and lots of biodiversity research is made with observing, modeling, documenting species individually, independently, as if they never interact with each other, which is biologically incorrect. Of course, species interact with each other in the natural systems, they interact with humans, they interact with livestock, wild species come to the fields, forest species come to the cities, and all that is very densely interwoven. But until now, we didn't really study taking all that complexity into account. So on the most difficult end of our use case spectrum, we have these species interactions in the context of human diseases, emerging human diseases and vector-borne diseases, but also interactions between plants and insects in the context of pollination, which is closely related to the food security and very, very real problems which become increasingly important in the world we live in.